Welcome to Lesson 1, Rotations. This is another one of the transformations that we are going to be studying. This is your third transformation. Our objectives for this transformation are to be able to rotate an object around the origin and to define rules for rotating 90, 180, and 270 degrees. One of the mistakes that people make when they are performing a rotation is that they confuse it with a reflection. If you'll notice in this far right picture here, this triangle B actually rotates as it moves around the coordinate plane. So if you consider the top right here of B on the far right, when it rotates 90 degrees, the top is now facing up. Think of it like the Earth revolving around the sun. Not only does the Earth revolve around the sun, but the Earth also revolves around its own axis at the same time. You can see this happening in the middle graph as well. You can see that this triangle on the right actually rotates for rotating about the origin. One thing I want you to notice is that when you rotate 90 degrees, it makes a perfect right angle. 90 degrees should be a right angle. Okay, let's go ahead and define some rules. So we are going to start with a line because a line is the simplest thing to rotate, and then we can make some rules from rotating a line which we can apply to rotating a shape. In this line, I've gone ahead and put some coordinates for the endpoint. It's at 6, 4, and then I've conveniently put the other end right here at the origin. We know that if this line rotates about the origin, then this point will stay fixed. It'll be easier to rotate. Okay, let's go ahead and rotate this line 90 degrees. So I know that it needs to make a right angle, so I'm going to move it right about here. And you can see that this is a pretty solid right angle. If I wanted to double check, what I could do is I could get a piece of paper and put the end in here and make sure. Now what I'm going to do is record the coordinates of this endpoint. So it looks we're at -4 and 6 is where we are. So -4 and 6. Okay, maybe right now you're able to see a pattern. But let's go ahead and do another rotation. Let's take this line and rotate it another 90 degrees so that we can get to 180 from here. We can do that. We know it needs to make a right angle. Or we can take this line and just keep extending it out because 180 degrees is a straight angle. In fact, let's actually go ahead and just extend this line all the way out in order to make that straight angle. That way we know we've done it perfectly. And then we'll go ahead and record the new coordinates of this endpoint. So this endpoint looks like it's at -6, -4. Okay, great. Now we can do that again. We can rotate another 90 degrees, so we could take this and make a right angle, or we could take this line here and we could extend it out to make a straight angle as well. And I think we'll go ahead and do that. Okay, so now we've extended it out. Let's go ahead and mark these coordinates as well. So we're over at 4, -6. Now I have coordinates for all of my lines. Let's go ahead and mark these though correctly so that we know which one is the original and then which ones are the reflected images. So this is A, we'll call this point A. So this then has to be A prime, and since this was our second rotation, we'll call this A double prime, and then our third rotation over here, we'll call this A triple prime. This basically tells us that we started here with this line, reflected at 90, then reflected at 180, then reflected at 270. So each of these three lines are reflections. Now let's mark in here so that we know this distance here, this was 90 degrees. Then we took our original line and we rotated 180 degrees to get to this place, and then we rotated it 270 to get our A triple prime. Let's try to come up with some rules. The easiest way to do that is to write the coordinates of the original point and then the rotated point and see if we can see any patterns. Okay, so what I've done is I've written down our original point, which was 6, 4, and I've listed that as xy. That was our original xy. And then I've listed the rotated point that we came up with for each of the rotations, 90, 180, and then 270. So now here's where we have to look for patterns. So what happened to our x and what happened to our y in order for this to happen? Well, if you'll notice, x and y switched places. So now we have y, comma, x. But it looks like something else happened as well. Our new x, which was our old y, the sign flipped. So we have to multiply by a -1. So I'll put a minus in front. And that means switch the sign or multiply by a -1. Had this started off negative, it would have become positive. Okay, good. Now we have a rule for 90 degrees. Let's come up with a rule for 180 degrees. So what happened here? Well, our x and y, they did not flip places. They're in the same place, but it looks like they flipped signs. So we need to multiply both the x and the y by a -1. We need to take the opposite sign. All right, down to our last rule. For 270 degrees, again, it looks like the coordinates flopped places. So now we have y, comma, x, but our new x, or I should say our new y, which was our old x, now has a negative in front. So those two switched signs. So we need to multiply the x coordinate here by a negative. Okay, very important that you write these rules down in your notes because it's very difficult to rotate an object, like I said, if you don't have the rules to help you. Let's go ahead and try an example where we use our rules. Let's take this triangle, for example, and let's rotate it 90 degrees. Well, the first thing, the way to get started, is to write the original points down and then apply our rules. All right, I've listed all three of the points. Now let's remember the rule for rotating 90 degrees. Remember that x and y switch places everywhere other than 180 degrees. So we know we need to put a y here and an x here. And if you look in your notes, you know that we need to multiply our old y by a negative. So we switch signs. All right, let's go ahead and do that. So our new a, our image, is now going to be 4, 6, but then we multiply this 4 by a negative. Our image of b is now going to be 4, 0, but we multiply the 4 by a negative. And finally, our image of c will be 0, -4. If we multiply the 0 by a negative, we still get a 0. Now we're ready to plot this. So we're going to plot a at -4, 6, and be careful to actually mark that so that you know which vertice that is. And b is at -4, 0, so b is actually here. And then c is at 0, -4, which is here. Okay, all we have left is to connect our dots. And now you can see how this object has been rotated 90 degrees about the origin. And that would be very difficult to eyeball to do without actually using the rule. All right, let's try a 180-degree rule. So in this case, once again, let's go ahead and write our coordinates. Now that we've written our coordinates, let's recall our rule. So when we rotate 180 degrees, we don't change x and we don't change y. They are in their same places. However, we need to switch the signs on both. So let's go ahead and do that. So instead of having 6, 4, we would have a -6 and a -4. For b, we would have a -0, which is just 0, and a -4. And then for our c prime, we would have a +4 and a -0, which is just 0. So notice that this doesn't mean make it negative. It means multiply by a -1 or switch the sign. Now we are ready to graph. So we can plot our points. Here's our a prime, our reflected image. And then we have one at 0, -4, which is our b prime. And then we have one at 4, 0, which is our c prime. Again, all we have to do is connect our points to form our vertices, and now you can see where this triangle has been rotated 180 degrees about the origin. Let's do one last one before we go. Let's rotate 270 degrees. All right, I have my 3 points written out, and now I just need to recall my rule. Well, remember that our points are always going to flip-flop anywhere other than 180 degrees, so we need to write y first and then x. And then if you look back in your notes, one of these, we need to take the opposite sign, and it's going to be our old x here, our new y. So we need to take the opposite sign. Let's go ahead and do that. So let's flop the spots, and then let's take the opposite sign. So in this case, we would flip and get 4, 0. If we take the opposite sign of 0, it'd still be 0. And then here we have 0, -4, but we need to take the opposite sign of -4, so that's +4. Okay, we are now ready to plot our points for a 270-degree rotation. So our A prime is here, our B prime is going to be here, and then our C prime is 0, 4, which actually aligns here with our old B. Now, if we connect our points, we have our triangle that has been rotated 270 degrees. And that concludes our lesson today on rotations. Remember, we are rotating an object about the origin. It is different than a reflection, and it is important for you to make sure that you have these rules in your notes when you are performing the practice to make sure that you rotate correctly.